Without further ado, today's session is Harnessing Data and AI for Hazard Impact Mitigation, and it explores how emergency managers and planners are using big data, analytics, and artificial intelligence to better understand risk, anticipate impacts, and support decision-making from across the disaster lifestyle. Please help me in warmly welcoming our guest speaker today, coming all the way from Sao Paulo, Brazil, Gabriel Savio, CEO of Sipremo, which will share how data and AI can be applied to support real-world hazard mitigation efforts. So, Gabriel, thank you for being with us today. Mahalo and aloha, and I'll turn it over to you.
Hey guys, Malaho, aloha, oi, tudo bem? From Brazil, São Paulo. It's a pleasure to be here, and I hope we'll have for the next minutes great informations for you to understand how we've been applying, well, the fancy technology from AI on real world applications. I'm talking from Brazil, but our company is global, so we do have operations in the United States as well. So uh, many of the applications here and great part of our background was in United States. So we're close than you could imagine. So um, as you already seen, I will talk about this hazard data and AI for hazard impact mitigation, starting with our company, which is called Sipremo. I'm the CEO here, and here is where we support intelligent decision making for companies and governments alike. We developed an AI which is capable of providing information on where, when, and what kind of natural disaster or weather event may occur in the future. And our technology support these decisions. Once we are able to understand these conditions in the future, we apply these forecasts, these predictions, this analysis on specific operations to comprehend how they will be impacted for these conditions, and not only tell them that these conditions will happen in the future, but still tell them how these conditions will impact their daily lives and how they can deal with this on a proactive and a resilient way, which is most important for us while we're dealing with all these climate change events. Well, talking about the problem we are solving, I think it's, well, as they goes easy to explain. I don't know if you have ever faced one natural disaster in your real life, but the spoiler is that if you didn't feel it yet, you will. In the next in the next years, you will feel directly or indirectly on your life. So it's easy to explain how these events are increasing their frequency and the intensity. We see all of these extreme weather events impacting various industries and communities around the world. Especially here in Brazil and in the United States, we can see what happens every year in Florida and in California. Here in Brazil, have a lot of floods in South Brazil and a lot of drought in the north. So everybody's facing it, and the spoiler, as I said, is that this frequency and intensity will increase for the next year. So we have to have solutions to deal with this on daily basis. Once we already made a lot of bad things in the past, so we have to do all this carbonization things, the great practices around the environmental. Of course, this is very important, but we already made a lot of bad things in the past. So we have to have solutions for now to deal with this on our current life. So besides the increasing frequency, we still know that we have a critical gap on a comprehensive weather risk predictions. I'm talking about not only the short term, but the long term too. We have a critical gap between these two different positions of the weather predictions. And this is one of the most critical applications because once we don't know what is happening in the short term, we can't proactively act and respond to these events on the short term period. And when we don't know what's going on the long term, we cannot be ready to manage our environmental to be more resilient and be proactive dealing with these events when they will happen. So manage the assets, manage the teams, manage the infrastructures. When we don't know the long term, this is very impacted. And when we don't know the short term, the responder actions are always impacted for this. So we have a critical gap between understanding on these different perspectives, applications of the analysis. And as I said, many sectors are being impacted for this. You see big numbers in the next slides, and it's easy to understand and see how these events are being impactful for everybody, from government to private industry and various industries too. And as I said, this uniquely differential experience we have to understand these conditions from hours to days, weeks, months, and years ahead is what is happening to acquire technology on support this intelligent decision making once we have all of these huge problems to deal with. Talking about the weather forecast scenario in 2026, I can tell you that we will have great focus on these short-term applications. I'm talking about 1 to 14 days ahead. Once the people, as I said, have to deal with this on the daily basis, and considering we already made, as I said, a lot of bad things in the past, companies are looking to have these solutions to deal with this on these short terms once the thing is happening. So they already facing these challenges and these problems on their real lives. And the hyperlocal emphasis is one of the trends as well. Once we have all these different conditions on so close places, and the impact of these conditions on each of the operation, on each community is being even more different than we used to have in the past events. So understanding these hyperlocal applications is very important, and it's a trend for this year too. I'm here in Brazil, São Paulo, and now it's currently raining here. Actually, we're having like a thunderstorm. I'm seeing a lot of thunders here from a window, and this is something that is it, it's very it's very uh, difficult to understand, because some things that used to happen here in São Paulo, Brazil, is that I could have this kind of thunderstorm I'm having here now, and like in the next neighborhood, they will not have any kind of rain. And this happens with a great frequency here in Brazil. So having this hyper-local emphasis is one of the trends for 2026. As I mentioned before, the gap between the regional level and the long-term prediction too is one of the trendings, and well, it's a very important gap. Once we don't have this support for long term, and we have a lot of gaps on the short term, dealing with this is increasing of importance in every operation. Once people are already understanding that these conditions will increase and they have to deal on short term, but still understand how they will be impacted in the long term and manage their operations from this perspective too. And of course, the vertical and loose approaches, once we understand these conditions, From the weather perspective, it's been even more important to understand how they will impact all of the operations we're working because you will see in the next slide some examples of it. But we have in Sipremo some operations that when we're having these kind of conditions here with thunderstorm, they they like this. It's good for their business to have this, but for part of them, this is one of the worst things that could happen. So understanding how these conditions will effectively impact is being even more important and understand how to deal with this is what's making the difference for the intelligent decisions and support for this intelligent decision in the futures in the company's planning. So understanding this allows the users to mitigate problems, to mitigate negative impact, and to understand how they can take advantage sometimes of these conditions as well, helping them on managing and all of these events and respond there too. As I said, some big numbers for you guys to have it even more clear on how these weather events and natural disasters are impacting our lives. These are numbers that, well, you can see that they are very relevant. Well, $380 billion of impact around the world caused by natural disaster. This is not a number that you could pass. This is very important one and shows how important is this from the financial standpoint, of course. For more than 75 of the corporations, these events are already impacting the supply chains and their operations. And for the governments, critical infrastructure is one of the most sensitive points. More than 3% of the GDP delivered only for these kind of repairs on roads, bridges, and all of this infrastructure. And talking about ourselves, more than 10 million people are already being impacted for these events directly. So this number is increasing in the last years. And as I said, it will continuously increase. And we have to have solutions to deal with this on the best way. And well, as I said, just a quick background about where we were and where we came from. So Supremo is a U.S. and Brazilian company with a technology that was part developed inside the São Paulo State Civil Defense, which is the most relevant player in South America for this kind of events. So we were with them for more than 5 years developing the Brazilian part of the technology. And part of this technology was developed inside the US Department of Defense too. And with this amazing background, we could have amazing opportunities to explore, stress, and apply our technology on such a different conditions and stress as much as we can with two big players to until we reach levels to where we are today when we have different applications in different industries and a proven solution that supported us with all this background, which is unique for the technology standpoint and offered us the chance to work with so many different conditions in two of the most susceptible places from the weather and climate change events perspectives in the world. As I said, we have operations in Brazil, United States too, but in Europe and in Australia too. So all of these applications you see in the next slides. we have been applying not only in US and in Brazil, but in some different countries as well. Talking about our technology, as I said, we developed an AI which is based on an artificial neural network using a semi-supervised model to understand how the variables we are offering for this AI can interact between them until we reach the predictions. And then once we have those predictions, we do the contextualization of each of the application we have. This AI is based on two different verticals, basically. We divide these two different verticals to organize the variables we use here, the data we use. And these two verticals we use to separate in the dynamics informations and the 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 ones that doesn't change with a high frequency. So the absolute ones. So these two verticals we divide the informations. We can the way we divide these two verticals with the informations from the dynamic ones and the absolute ones, we can absorb in our AI and connect all of these informations to do our analysis. Just so you understand some examples of these two verticals from the dynamic standpoint, I'm talking about all the variables that are changing with a high frequency. So humidity, satellites information, radar information, precipitation levels, temperature, all of these things that are continuously changing, we define as dynamic ones. And the absolute ones, I'm talking about the geological information, hydrological information, geography information, even social patterns we consider in our analysis too. Because once we have these two verticals done, we are able to understand what we have in the places we are working and all the conditions that will not change in the next day, but maybe will change in the next century. So we consider as absolute ones and combine with the dynamic ones to connecting these two, understand how they will influence on the places we are covering to um, to make an event more susceptible for the next period. Once we have these two verticals divided, we we work in three different layers in our AI. First one is where we take these two different verticals with all of these, I can tell you, million of variables in our data sets to input in this first layer. So this is where we do effectively the input on the AI. So it can deal with a geological information that has this kind of standard and meteorological information that has this kind of frequency and this kind of source from this kind of regulation too. So this is one of the most difficult parts of our technology to have all these informations available enough for the algorithm to do the analysis. And the intermediate layer is where the analysis happens. So it's where replicating our brain, we have this neuronal network connecting all of these informations we offered in the first layer, connecting the river level with the geological pattern, with the precipitation level from yesterday and the current one. It connects everything and defines all the waves and the importance of all of these conditions for every single place we are working. And once it's done, we can see the results and the output layer. So here is where we have the final results of our analysis, where we are able to see how these huge amount of data were processed, and now we are seeing the forecast. And then we have the process to connect with all the industries we are working and the conditions of how these will be impacted for on every operation. These are just a short list of events we're able to forecast. As you may see, you have some things that are more relevant for short-term information, short-term predictions, just like hail, flood, storm, flash floods, and some things that are important for the long-term decisions too, like La Nina and El Nino conditions as well. So once we're able to understand all of these conditions in the future, we're able to understand the impact on every operation we are working. And to have this AI, have this AI allows us to apply on so many different conditions. These are big, the big two products we have here. The first one is called Sipremo Core, where we take these analyses, understand the future, how they will be, and understand the impact on every operation, as I'm seeing from the short period until the mid period. I mean, hours to days and until 4 weeks. I'm still talking about the Supremo Core. When we go ahead of it, we apply our region what, we are able to understand 1 to 12 months ahead how the conditions will be in every operation, in every place we are working, and then apply on every operation we are working. Uh, as I think you already got, we have so many different potential applications of this technology, not only for these ones. I will show you where we are already applying it around the world, but we still have the healthcare application, the events applications, and much more to explore as well. So once we have these two big products, we take the technology on the to the field to apply effectively on real life operations, where we could see how these AI results are helping the people to deal with this on the real operations. So we have applications today for the forest industry, for the oil one, finance, government, insurance, and mining too. So all of these operations have specific conditions and has specific ways to be impacted for the conditions we're forecasting. And the way to show this and the way we understand the conditions and show to them how they will be impacted for this is what makes the difference from disaster that will cost me $1 million and responder action that will save me a lot of problems. Um, so for the government's operation, we take the core of the Supremo Core one, where we're able to understand. And well, today we have more than 1,200 cities covered. And it's where we're able to support this urban plan through the long-term windows and the emergency responders team on the short-term opportunities windows too. Here is where we take the cities, map all these variables and 1,000 more that I didn't explore with you guys to understand How are the conditions from the absolute perspective? We track all the dynamic ones, combine it to and do the analysis to understand in the short term where, when, and how the events will be happening in the next hours. And with these informations, we alert the responders teams to understand where they have to go to be ready to support the people who will be impacted for this on the short period. And on the long term, they have this analysis with the susceptibility maps to understand where they have to deliver resources, to deliver infrastructure actions to change the perspectives our analyses are showing to them. So it supports a lot of important decisions for the governments from the planning standpoint and long-term time window and um, the short time one where we support is responding actions on uh, our basis. For the mining industry, we do take the same analysis as you see. We goes from the same core, the same AI to do all of these applications. And on the mining ones, we take this analysis and offer for them the contextualization of this to make them understand how they have to manage their operations from the safety standpoint and for the operational standpoint, I mean the extraction of the mining operation, and for the management of the assets, the relocating of the equipments, all these things. They can have this analysis for the next hours and the next days. And with this information, they can understand where to manage and how to manage all these conditions on their operations. And as I said, this is one of the examples of applications where they have this analysis not only to deal when an event is happening, but still understand when it's not potentially happening and manage these opportunities windows to do the operational on this as much as they can be strategic on that, considering this perspective to support the decisions too. We still have the personalization of the emergency plans communication. So we integrate this analysis with the emergency plan communications and do all of this with one and only integrated solution for them, supporting very important decisions on their daily basis. For insurance operations, we do the same analysis we do in the core, but they use to understand where to relocate the responder teams, understanding how will be the amount of insurances impacted for these conditions in the next hours. Besides, understand how these insurances are being exposed to every climate risk we have mapped. And with these conditions, they're able to understand and have a lot of indicators to comprehend all the profiles of every people on the ecosystem. For the oil operations, I think this is one of the most interesting ones we have. We have something like a year and a half of operation of it, and it's where we take our analysis as we already got. We see how the conditions will be in the future, and here we apply to understand once they have an oil spill, how this oil spill um, will be in the next periods. So in the next 5 minutes, 10 minutes, 15 minutes, an hour, we are able to do this analysis on this short periods and support them, telling that this oil spill will be at this place in this next opportunity window, supporting the responder teams to act as fast as they can on these conditions and uh, mitigate all the negative impact for the communities and of course for the environmental too once we're talking about something that has very important levels of impact in the environmental. For the banking operations, we take the long-term analysis to understand how every project they are considering to work to finance will be impacted for the conditions we're forecasting. So once they have this information on their hands, they can understand how vulnerable are all of the events they have working and understand if it makes sense for them to go ahead with this deal or not. So supporting these kind of decisions here in Brazil, we saved some millions Brazilian reais for one specific bank, talking about the floods that happened in 2024 in South Brazil. When you had the chance, try to Google about it. You see how it was very horrible for all the community there. And once they had this information, they already got how to deal with this, considering that this place with this activity will be potentially impact for the next years on these and these levels for all of the events we are working on. So these allows them to understand and mitigate this future impact through our technology, as is the theme of our conversation today, applying effectively AI analysis from weather perspective to real life decisions and actions. And well, this I think is one of the most outside of the box applications we have here, where we take the same analysis where you already got how we do. And basically, once we have this analysis done, we are able to understand how these conditions will influence on infestations for the forest operations. I'm talking about eucalyptus here. So once they have these informations weeks ahead, they are able to understand where to go, how to manage, how to deal with this, and it allows them to decrease the insecticides applications on the operations. And this helps not only the operation to save money because it really um, um, it costs too much, but of course it allows us to generate a great impact for the communities around and the soil, the ecosystem at all. Once they have the opportunity to change these pesticides applications to other and different ways to deal with these infestations, once they have this information weeks ahead, we are taking the weather analysis through our AI to support real decisions on real life. So here is one more great example of this relationship. As you saw at these applications we have today, they have a lot of particulars, conditions on their operations. So we do have resilience as one of the keywords for all of the solutions and of course for our technology too. So our technology has to be resilient too, to be applied through an API and a cloud dashboard, an app or a report. We have a very different, a very huge deck of applications of our technology through all of these different products to all of that industries I just explained to be even more precise on what we're delivering for every industry we're working in, making them understand how the weather will impact their operations as easy as they can and support these decisions making from the most proactive way we can. Well, talking about our key differentiators, I can tell you that we have these great background with this experience developed inside the U.S., the Department of Defense and the São Paulo State Civil Defense, which is uniquely around the world and made us being good enough to have all of these perspectives. But to have this data interpretation, as you got the major differential of our technology is the potential to understand these conditions on different opportunity windows, but understand how they will impact every operation and not only tell them that, hey, tomorrow you have 20 millimeters of rain, so deal with this. We're able to understand that these 12 millimeters of rain will impact this forest guy on this way and this mining guy on this way, and this will be an opportunity for this other guy. So this allows the users to deal with this information on the best way they can, understanding effectively what they have to do on their operations to deal with this on the most proactive and resilient way, which will save money, save lives, save resources, and much more. And they will have much more support for their operational decisions. Well, still talking about our differentials, we have this solution fully scalable. We're able to apply basically everywhere once we don't work with any kind of hardware. We have all of these analyses through private to public sources, to national to international sources, and from partners and clients too. And we have a very great network of it. What allows us to do all of these analyses without install any kind of hardware, helping us on this scale, and of course, scale on the application of the technology. We're able to scale the impact too once we have all these conditions around the technology. Well, as you already got our operation principle talking about the full cycle weather risk prediction. This is one of the most important things for us. Once we are able to do this analysis hours ahead and years ahead, the continuously technological advancement to understanding will how they will change during this period, and how can we apply on this real application through the most advanced technology we can. It's very important for us, and of course, understanding the real scenarios and the real applications of this analysis and how they can effectively in real life help the people to deal with the conditions on the weather. Well, for the benefits, I can tell you a lot of things. All of these applications has specific KPIs. I added some big numbers when I was talking about them, but you can see that having this information from the short term and the long term will help, of course, on budget planning support. The cost of the resource deployment, of course, will be impacted for these too. Once you have this information to support your planning, all of your resources, you will have much better decisions than before. We have great values, as you can see. All of the support happen impacts on different levels of operations with a considered low cost compared to the costs they have when they are reacting to these events. So this relationship between having a solution to allow you to be proactive on this perspective, besides react to this, makes totally difference when you're seeing from every perspective, from the resource to finance, to humanity. Every perspective will make sense. Of course, the enhanced disaster management with this information will be even more increased for the perspective with all of this information too. And the optimization of the decisions, as you saw, once we have this support to have real data-driven actions, you can deal these events on the best way you can. So these events these are the most relevant values that the people can have by working with this kind of technology. This is our C-level team. We have a lot of people working with us, but I am the CEO. We have Renato as our CTO, Jefferson as our CDO, Bruce as our CSO, Renato COO, and Kaushal working with me on the strategic level. We do have meteorologists, engineering, developers, data scientists, and a lot of big hat guys working with us to make these things happen. So I try to be straightforward to the point, especially on the applications, because I think it's very important for us to understand uh, how these technologies people are talking, we can apply on real life. And this is a real life application with real life results, solving a real life problem too. So I hope you understood, and sorry for my accent. I know that I have some words that I miss in my Brazilian accent, but I think you got it all. And this is Sipremo. We're technology forecasting the future and ensuring our present. Thank you, guys. I saw some questions here while I was talking.
Right,
So,
Gabriel, I can help you with that,
cool.
definitely. So the first question is from Amy, and she says, how do you handle data quality and bias when inputs come from multiple sources and jurisdictions?
Wow, this is one of the biggest challenges we have here. Once we're dealing with so many different sources with different types of data, deal with this is very challenging, I can say. So we have a methodology to take this analysis, divide on these two verticals I explained, but even divided on these two verticals, we still have another, I can say, another layer of work with these informations to um, kind of normalize them on the frequency, on the type, and and validate the quality of it as well. We have, as I said, this this network that allows us to do this analysis and use this network data to do our forecast, but we still use this network data to validate our forecast and validate our data too um, on different data sources too, providing the same information. So we have this kind of methodology to normalize the data, validate, and try to uh, make sure that everything is on the best levels we could have to do the analysis we have. Because once we don't have the high quality of data, the final result of analysis will not be that high too. Doesn't matter how better is your AI model, if you don't have a great input, the output will not be good enough, will not happen. So that's it.
Awesome. Thank you for answering that question. If anybody has any more questions or comments to put in the chat, right now is the time to do so. The next question is from Mary, and she says, are you including space weather?
We're using space data to do this analysis. So we have like every um, oh my God, the English word for the satellite that stays specifically on the place and doesn't change the his orbit. We have all of this mapped for the places where we are, as I mentioned, South America, US, and the other places too. And all the public satellites we have in our data sets too. So we have using the space data from this perspective.
Awesome. Next question is, what data gaps most limit effective hazard impact modeling?
That's a very interesting question too. Uh, it impacts on the especially, of course, it will impact on the final result and the first steps of the operation. But once we start, our technology is able to to learn when the operation is running. So we can take the feedback for the operation and transform it on a training session to our AI, and it will mitigate this situation. But it will impact a lot on the the knowledgement level of this. So all of these AI models goes from low level of accuracy, and when time goes, it keeps increasing and reaching the best levels. And this will be the most sensitive point of this kind of gap. Once we don't have this as good as we can, we will have to pick from the operational standpoint and try to find ways to retrain and keep this progressing of the occurrence of the model continuously, and it will cost a lot of hours work, processing and time to do this, so it will really impact on this point. And it's very important because, well, as I said, we start with, for example, 50% of accuracy, looking to reach an 80, 85 uh, in 3 months. If we don't have this good enough, we will spend 6 months to reach it. So all the operation will be impacted to this. Meanwhile, the data gaps is happening.
That makes sense. All right. Any other questions, comments? You folks can also feel free to unmute as well and ask the questions at this point. We have around 8 to 9 minutes left. Just want to make sure that everybody's, curiosities are satiated. Oh, we just got another one. Also from Amy. What are the biggest risks of over-reliance on AI in hazard planning?
Um, the risks are, well, they are related to the actions they will do besides before having having the analysis. So we used to positionate ourselves as a tool that support intelligent decisions. So this way, we're not defining that you have to do this, so or you have to do that. We're supporting decisions. So it will have mistakes, of course, just like every AI model will commit some mistakes in that. And the users have to consider that they will potentially have mistakes on that and understand that we are not defining that they have to do this specifically thing, because we know all of the implications from the human to operation to finance standpoint. We know all of these things. We analyze all of these perspectives. We understand all of these conditions and tell them that they have these conditions potentially to happen, and these are the actions they have to do to mitigate or deal in any level with this condition we are forecasting. This is the key point of the risk, because once they understand that we are supporting their decisions, they can understand how to use the solutions and have these kind of results showed during my presentation on their operations. But once they don't have this clear enough for them, and well, we have two situations on this point too. Well, the one that takes all of our analysis and goes straightforward without thinking anything on that, and suffer with the mistakes, and the one that take the analysis and say, okay, uh, tell me the next numbers for the lotto. It's not happening. So we have these two different profiles. Nowadays, we don't have uh, that relevant number of this second profile that tells me, oh, come on, okay, you're telling me this. How do you know this? We don't have this kind of profile on relevant numbers anymore, but the other one we have. It's curious because when we started, people used to see all of this technology and understand that we are predicting the future, and they typically asked us, as you're predicting the future, tell me the numbers of the lotto. I want to be millionaire, so tell me this. If you're able to predict this, you can predict the numbers. And I said, come on, this is not the science we're doing here. This is not the technology we're doing here. And nowadays, we don't have, as I said, a relevant number of these uh, think wave people. But we have the other one which takes the analysis and goes straight forward without thinking in the impact of it. So it's a kind of a balance of it. We are supporting these decisions to them to understand how these conditions were forecast will impact their operations, but we are supporting decisions. So this way, once they understand the balance of it, the risks are mitigated because the risks happens and costs when it transforms from risks to actions. So this is the balance we are trying to apply on the users for them to understand how to take most of the advantage they have from the technology.
Thank you for answering that question. That was awesome. Um, I guess at this point it would be okay to close down. We're nearing the end of our hour that we've been together. So I just wanted to give a big mahalo to everyone for joining us today, and a very special mahalo and obrigado to Gabriel for presenting today. Uh, just wanted to set a few reminders as well that today's session was recorded, and I believe Amy dropped it in the chat, a link to our previous session she did. So that will be uploaded to our Facebook page and our YouTube channel. If you didn't get a chance to ask your questions or have any comments, please feel free to reach out to us at NDPTC. We can pass along any messages. Let's see what else. We just wanted to thank you all for spending your day with us, and we appreciate your time and participation. And we would like to tell you thank you, and we hope to see you at next month's Third Thursday webinar.